I'm just going to go through a multi-grid, and I'm going to talk over it and solve the answers. So if you want to just do it by yourself, you can do it along with me. I'm going to start the timer in a moment, but you might want to just mute me on the on Twitch, which is down the bottom left of that video window. Okay, so we're going to start in 5, 4, 3, 2, 1. So I think it was 3 minutes yesterday. All right. Today I was going to do a bunch of problems on adding, subtracting, and multiplying decimals. So that's what we're going to do today. I'm just going to leave this up because I would take a screenshot, just take a screenshot of this page, because that's all the stuff that we're going through, and you can use these numbers to track down the exercises that you. Let's get started. So okay, so with adding decimals, it's actually pretty much the same as adding regular numbers, but the main thing to remember is to stack the decimal decimal point. If you stack the decimal point, then it just becomes the same as a regular standard written form problem. So 7 plus 9 is 16. Carry the 1 up. 2 plus 1 is 3. 1 plus 4 is 5. So because we've stacked the decimal, we had our decimal point comes down here. 9 plus 7 is 16. Carry a 1 over. 1 plus 0 plus 2 is 3. And 5 plus 1 plus 4 is 5. And you can see that essentially we've ended up with the same numbers, but the decimal points shifted along. So I'll do another one just to, another few just to show you that works again. Okay, so if we have a problem like 57 plus 328, we got 8 plus 7, 15, carry the 1, 8 plus 5, what am I doing? I'm doing multiplication. 5 plus 2 plus 5 plus 1 is 8, and 3 plus nothing is 3. So you get 385 when you add those together. So if we're going to do a similar problem, if we move the decimal point back 2, then we've essentially, it's the same. So as long as you're moving your decimal points the same amount, then that's okay. So we're going to end up with, oh, what's going on there? Sorry. Oh, I wish I could undo that. It's a bit messy now. I'll just make the decimal point really pronounced. Okay, so 7 plus 8 is 15. 1 plus 5 plus 2 is 3. Decimal point gets carried down, and 0 plus 3 is 385. So you can see that we ended up with the same digits, but decimal points just in a different spot. Alright. Last one for addition. I'm not even going to do the original one. We're just going to, so our decimal point lines up here. So we may as well drop that in there now to start. and then we'll get down to the thousandths column. So yeah, that's another thing it's handy to know. We've got the ones, and then the next one over, it's not the oneths, it's the tenths. And this is the hundredths. So it just counts the same way. The next one over is the 10,000ths, the 100,000ths, and so on. Okay, let's just go through this. 3 plus 6 is 9. 9 plus 7 is 16. Carry the 1. 9 plus 1 is 10, plus 6 is 16. Carry the 1. 1 plus 1 is 2, plus 2 is 4. That's our final answer. Okay, subtraction. So if you wanted to do a little extra on that exercise, you could go through 2a to 2j, but we're going to move on to subtraction. All right. So this is exercise 2.05. So subtraction and addition generally always follow the same rules. So if in the same way that we could just add problems like this together, we can subtract problems like this. I really shouldn't have circled that. I've got a new pen and the rubber is kind of finicky. It jumps the screen around if I press it in the wrong way. It's not quite as good as my last pen, but it does have a laser on it, which is pretty cool. I'll show you that. So that'll be fun once I get back into the classroom. I'll be able to fire a laser at you if you're off task. Anyway, let's get to this problem. So just a bit of a jog your memory. If we're subtracting and we need to borrow, then we take one off the column in front, drag a 1 over to here to make that a 16, and then we've got 16 minus 9 makes 7. 2 minus 1, we don't need to borrow, so just 2 minus 1 is 17. Okay, so if we shifted the decimal point, so the decimal point lies here, and we just bump it over 1 in both the numbers, then we have the same problem. And we should end up with the same digits. So 6 minus 9, we can't do it, so we need to borrow from the ones column. So if we borrow 1 from the ones column, that's 10 tenths in the tenths column. So it works the same way in decimals. So now we've got 16 tenths there. 16 tenths minus 9 tenths is 7 tenths. Decimal point goes in the same spot. 2 minus 1 is 1. So we ended up with our same digits. 17 over here, 1.7 over here. Alright, moving on. So you're not always going to get your problems written in standard form, so you might be given a problem like this, and it's fine to just put that into standard form. But this one's pretty simple. You should be able to see that it's the same as doing 8 minus 2, really, which would equal 6. So 0.8 minus 0.2 is going to be 0.6. But you could do it in standard written form if you wanted. Whoops. Totally written that wrong. 8 minus 2 is 6. Carry the decimal point down. Got a 0. This is what ISO has come to play with layers. Yeah. Okay. Let's do a little bit of a harder one. So this one here we might not be able to do just by observation. So we might need to put this one in standard written form. So key thing to do is to line up those decimal points. So the next number is going to fit there. Alright, so now it's just a regular subtraction problem. We start from the right side. 1 minus 3, we can't do it, so we're going to borrow from the tenths column, change it to a 5, bring 1 up, bring 10 over, so that's 11 now. 11 minus 3 is 8. 5 minus 4, we can do that, 1. 0 minus 7, we can't do it, so we need to borrow that 1, put it into the other column. 10 minus 7 is 3. And 318, that's not our answer. We've gotten to drag down our decimal point. So with subtraction and addition, if you line up those decimal points, you're going to be golden. Alright, one last problem for subtraction. This problem. So in this situation, we're going to have some unfilled spaces that we're going to have to fill with zeros, because this has got hundredths and this is only in the tenths. But the key thing is line up those decimal points. So 14.5 minus 9.82. So I've lined up my decimal points, but there's nothing here in the square, so we'll put a 0 in there. We haven't changed 14.5. 14.50 is the same as 14.5. You can always put zeros where there's nothing to fill that space. It hasn't changed the number. Okay, so, but we don't actually need that 0 or that 0. We'll just delete it that way. Circle it. Alright, so 0 minus 2 won't go. We've got to cross that out, make it a 4, bring 1 across. 10 minus 2 is 8. That's an ugly 8. 4 minus 8, can't do it. Borrow 1 from the next column over. 14 minus 8 is 6. 3 minus 9 won't go. We're going to borrow. So we're left with 0 there. 13 minus 9 is 4. 4.68 is our final answer. Okay. That's enough for subtraction. And if you wanted to do any more, there's definitely more examples in exercise 2.05. I've just picked out a few that I want to display to you, but it's definitely worth you guys doing a little bit more. Alright, multiplying decimals. This gets a little bit harder because when you multiply by decimals, especially if you've got a couple of decimals, it doesn't usually work the same way as addition. Your decimal points compound. So I like to break up a decimal into its parts. So what does that mean? Well, if we took something simple, this is just how multiplication works, right? If we have 6 times 4, that equals 24. We know that. But 6 can be actually broken down into 3 times 2. And it doesn't matter which way you multiply 3, 2, and 4, any sort of order, 2 times 3 times 4 is also going to equal 24. So you can mix around the numbers and you're still going to come out with the same answer. So if you keep that in mind, we can think about a decimal. So 0.1 and 0.01 and 0.001 are special decimals, because what they do is they just move the decimal point over. So multiplying by 0.1 has the effect of moving the decimal point one move, right? Multiplying by 0.01 has the effect of moving it twice, 2 moves. So this can be important because we can split that out and go back to a normal multiplication problem. This one at the end, 0.01, it moves the decimal point 1, 2, 3. So then you're back to your original 4, 5, 6, 7 instead of 4.567. Alright, so just keep those two facts in the back of your mind, that you can split up numbers so that they are in smaller parts, however you do it, and also the fact that 0.1, 0.01, 0.000001, they all just have the effect of moving our decimal place along. Okay, so keep those two facts in the back of your mind. Alright, now if we come to do something like this, 8 times 0.6, what I think is a good way of solving a problem like this is to just change the 0.6 back to a combination of regular numbers and a 0.01 or 0.1. You get the idea. So 8 times 6 times 0.1. And now when we're working this out, we know how to do 8 times 6. That's just a regular times table. So 8 times 6 is 48. And then we've still got that 0.1 on the end. But that's an easy thing to work out because that's just going to move our decimal point along. There's nothing strange about that. So that will move it. Well, a good way to think about how much it's going to move is how many zeros are involved. So I'll come back to this idea. But there's 1 0 involved, so it's going to move one place. Alright, so 48 becomes 4.8 when it's multiplied by 0.1. So the answer at the start, 8 times 0.6, is 4.8. So we haven't used anything other than regular times tables and this notion of moving a decimal point along. Okay, next one. A little bit harder. Not that much harder though. So 0.07 can be broken up into 2 times 7 times 0.01 because it's been moved twice, right? And there's 2 zeros involved. So 2 times 7, that's 14. And then we'll just leave that on the end. Now, if we were to move, we know that a 0.01 moves it twice, so our decimal point is going to end up here. And there's going to be an extra 0 that we're going to need to put there to take its place and make the number make sense. So our final answer is 0.14. 2 times 0.07 is 0.14. Right. Let's try this one. So 8.9. How could we break that up? That's going to be 89 times, well, it's only moved the decimal point once, so 0.1. And then that's still multiplied by 3. Alright, now this is a little bit trickier because we've got a 2-digit number, but basically what we've got is 89 times 3, and then we've got a shift of, well, let's not call it that. Sorry, I just need to delete something. I want to do that on read. So this is our move 1. So if we work out what 89 times 3 is, then we just need to move the decimal point over once. Looks like someone's already done it. But I'll just do it nice and slow. 9 times 7 is 27. Carry the 2 up. 3 times 8 is 24. Plus 2 is 26. So that problem would get us 267. But then remember that we've got to move 1. So the decimal point was here, and it gets dropped in there. So our final answer is 26.7. So well done, Josh, for just racing ahead and getting that one. Alright, this one here is quite a bit, well, it's not that much harder. This time we've got 2 sets of decimals going on. One's getting moved by 1 place, and the 1.23 that's getting moved by 2 places. So I'll show you how this works in the breaking it up method. So 1, 2, 3 is 123 times, well, think about how much we've moved it. We've moved it 1, 2 to get to there. So this is going to be a 0.01. Then with our 4.5, we've got 45 times, well, it's only been moved 1 spot here. So that's going to be times 0.1. Alright. Now, so this is a 2 move, and this is a 1 move. So if we add those moves together, we've got a 3 move. And then the only thing that we need to multiply together is those 2 regular numbers. So 123 times 45 gets us 5 times 3 is 15. Carry the 1 up. 5 times 2 is 10. Plus 1 is 11. Carry the 1 up. 5 times 1 is 6. Is 5. Plus 1 is 6. We get 515 for that row. And then we're moving on to the 4. But remember, we've got to put a 0 here because that 4 is not a 4, it's a 40. 4 times 3 is 12. Carry the 1 up. I should cross these out so we use them. 4 times 2 is 8. Plus that 1 is 9. 4 times 1 is 4. There's no counting over because it's such a low times table. And then we add them up. 5 plus 0 is 5. 1 plus 2 is 3. 6 plus 9 is 15. Carry the 1 over. 5 plus 1 is 5. And then we have got 3 moves. So 1, 2, 3. Our decimal point's going to line up there. So our final answer is 5.535. And if you think back to our original problem, we've got 1.23 times 4.5 if you are just estimating it, sometimes you can get where the decimal point is by just estimating. So we've got approximately 1 times approximately 5. So 1 times this little symbol here means approximately. Approximately 1 times 5 equals 5. So if we know that our answer is going to be approximately 5, then that's just a little check to make sure we've got all our decimal points in the right order. But don't worry too much about that. We'll try and develop that skill. Alright. I think that's the end of all the content I've got. So I'm going to pay attention to the chat now. If you would like to ask me anything about how this is being run, I'm going to try and post these videos the following day at the same time that the stream would be. So, for example, tomorrow I'll post it at Saturday at maybe 10 o'clock, and on Monday I'll post it on Tuesday at 10 o'clock. So it's just going to be, I'm going to try and get it to be exactly 24 hours after the original one. And that's just because it takes a bit of time to edit these videos and cut things out here and there. Like I'll probably cut all this out. Well, I might not, because depending on whether I think it's important to the video, I might cut a few things out. So that's taking me a bit of time, and I left that time. I knew it was always going to take a bit of time to learn how to edit videos and do all that. Also, yesterday I figured out how to reduce the clicking sound of the tapping of the pen on the screen. I have to pull the audio out into another program, and then I run this click removal thing, and it takes out all the clicks, and then I take that audio file back into the video file and match it up. So I'm using 2 or 3 different programs to make each video. But that's actually quite fun. All right, I'm going to stay on for maybe 5 more minutes. So if you've got anything, post a question on the chat, and I'll just sit here twiddling my thumbs while I wait for you guys to tune in. Oh, Emma. Emma says, do we need to send you a photo of our work once we've done it? You can, yeah. I would. It's not essential, but I like to see the work that you guys have been doing. It's been really great to see that some of you have been sending me emails of the work that you've done. So yes, I would love it if you'd send me your work. But at the same time, we're just starting this up, and I just really want you guys to be tuning in and watching the videos, and also filling out that form. Has anyone already filled out the Google form? Oh, you might miss that. I'll just pull it up on the other screen. Oh, look at this. It starts streaming. You can see how much lag time there is. Oh, that's interesting. Anyway, on Schoology. Oops. What's going on? Things timed out. Courses. Both my Year 9 classes are the same. So hopefully you guys are still able to access the textbook. So that's the textbook Alpha E2. And in this week, I wanted you guys to maths in the bubble form. So that looks like this. I just want you to check these boxes. So these are all the things that actually I've turned the OneNote. I might as well turn that back on. You could try and get into that, but that's not totally necessary. Well, you must have seen the announcement video, seeing as you're already on Twitch stream. And yeah, have you been able to get on the Twitch stream? Have you been able to do Math in the Bubble episodes on YouTube? So that's all that is about. I just want to know what sort of outreach I'm getting to, which students are able to see all this stuff, and which are maybe a little bit confused and don't know what's going on, which I think there might be a few. What else? Oh yeah. So if you're, I'm gonna republish this the OneNote. So if you click into the OneNote, it won't. You got to know that when some files don't open within Schoology, and when that's the case, you need to click the title of the thing, and it'll open it in the tab. So that should bring you to the OneNote, which may not work for some of you. I think you have to have a Microsoft account. So some of you might be using iPads and stuff like that, so you may not have a Microsoft account because OneNote's a Microsoft program. But you can sign up for all of that if you want to, and that's just a way of accessing all of my content that I've done for all my classes. So today I did this in 9BK3. Should remember to copy it over to B4, but if we scan all the way down to here, it hasn't loaded up today's episode, but it's up to date with what we did yesterday. So I actually messed up the stream yesterday, and basically some of the stuff I went through was just algebra recap. So just one-step problems, two-step problems, three-step problems. So you might want to check that out as well. So from while we're in lockdown, I'm just going to call them episode 1. So this is episode 2. And it'll be under this heading, Math in the Bubble. Yeah. Anyway, any final questions before I sign off? Give you 30 seconds to type in your answer. Alright, that's us for today, team. Hopefully you can check out those exercises, just do a little bit extra, especially with the multiplication. Um, that that might be the one thing that you do. You might just do a couple of exercises there, but otherwise, have a good weekend.